Hey everyone, it's Decoded here, and today we're diving into something that's literally everywhere atoms. But not just any part of an atom, we're decoding the mysterious number called the atomic mass. Sounds boring, but trust me, by the end of this, you'll see how it connects to everything from stardust to your skin. But before we move on, I want to show you this very cool picture. An AI generated picture of an atom, and it looks so pretty. I just told AI to generate an atomic structure, and this happened. Not an atomic structure, but it looks cool. Still looks cool. This is not related to the video, but I still wanted to show you, anyways. So moving on, what is the atomic mass? Well, over here we have the periodic table, and there's a little number below each element. And right now we can't see it because it was too blurry. So let's zoom into one of the elements, helium. As you can see, there's a little there's a number here. Now this is not the atomic mass; it's the atomic number, and this is the atomic number, this is the atom symbol, and this is the atomic mass. Ladies and gentlemen, we found it. Like this, like 4.003 for helium. For hydrogen, it's 1.008. For zinc, it's 65.39. And for carbon, it's 12.011. But what even is this? Well, atomic mass is actually before I tell you what it is, you know that atoms consist of three parts: electrons, protons, and neutrons. Well, I swear I'll do another video on atomic structure also. And um, well, like so we have electrons, neutrons, and protons. So technically, all three of them should create the atomic mass, right? I mean, technically, that's supposed to be right, but in reality, it's not. It's only protons plus neutrons. The atomic mass is the total number of protons plus neutrons in the nucleus of one atom. So now there's a question in our head: why not electrons? What did electrons do? Well, electrons are way too light to count. They're like the glitter of an atom world, pretty but basically weightless. Okay, now that we know what it consists of, why does it have decimals? That was my question. Why does it have decimals? Why not like a full number? Well, it's it's because of something called isotopes. Now over here, I have a picture of my notes. I'm so sorry if it's messy. Um, uh, like over here, we've used the example of carbon. So carbon has three different types of carbon. Those are isotopes. Now, crazy, shocking, right? So normally, you've seen that the carbon's atomic mass is 12.011. Atoms of the same element can have different numbers of neutrons, like siblings with different personality traits. So over here we have carbon 12, carbon 13, carbon 14. Now these all are the same, elements, same thing, but same protons, but with different neutrons, like with different personalities, like we've said in siblings. Um, like over here, we have the proton column, and we have the neutron column. Um, Protons, you'll see that they remain consistent. They're 6, 6, 6 for carbon 12, 6 for carbon 13, 6 for carbon 14, 6. But for neutrons, for carbon 12, it remains 6. But for carbon 13, it turns into 7. For carbon 14, it's 8. Of carbon 13, carbon 14, they have different neutrons. Now, this matters to atomic mass because protons plus neutrons equals atomic mass. And over here, I've shown to you, protons and neutrons 6 6. Now 6 plus 6 equals 12. That's the atomic mass. Now for carbon 13, it's 13.003. For carbon 14, it's 14.003. And ladies and gentlemen, that's why, actually no, I've not given you the answer yet. One second. So like these numbers, like carbon 12, carbon 13, carbon 14, like neutrons are different. They all have different usages also. Like carbon 12 is used for atomic mass standard, for carbon 13 used in MRI scans, and for carbon 14 used to date fossils. Now all of this, you know different usages. These are not worthless. And well, I also create another video for isotopes. Um, you'll check that out later. Um, and you'll see that, well, I'll explain in detail. But as you can see, like, this is like all these have different atomic mass, all different weights. So 12.011 is actually the weighted average of all of the natural occurring isotopes. Now, why is this there? And, like, why do we even have isotopes? Short answer: nature allows variety. Now, I'm telling you, you'll understand later. So, why does atomic mass even matter? Like, why should we care about what atomic mass is? Why, like, what does it do? Atomic mass actually helps with, calculating molecular mass, figuring out how much of substance to use in experiments, understanding the structure of the universe, and more, um, like helping chemists balance equations. See? They are really important. Atomic mass is really important. Now that we know pretty much, like, a good solid overview of, main idea of atomic mass, now I think we're ready for doing a practice question. So if an atom has 8 protons, oh my god, wait, if an atom has 8 protons, oh my god, no, I'm really bad at this. Okay, 8 protons. I've given up. No, no, I can't do this. 8 protons and 9 neutrons. Just listen. I'm not writing this. And 9 neutrons. What is its atomic mass? I'm pretty sure you have the answer in your mind by now, or if you don't, pause the video. I'm pretty sure you should by now. The answer is 17. Now, why? It's because atomic mass is protons plus neutrons, and clearly in the question I said 8 protons and 8 neutrons. 8 protons plus 9 neutrons. Sorry, 8 protons plus 9 neutrons equals 17. So that's the atomic mass. Now, now you know atomic mass isn't just a number; it's a code, a signature, a peek into the core of what makes matter, well, matter. Hope this helped you decode atomic mass once and for all. If you like this, hit that like button, drop a comment with your favorite element, and don't forget to subscribe for more glowy science videos with me, Decoded. Until next time, stay curious, stay awesome.